Hello everybody, welcome to this episode on statistics, and in this video we will be talking about experiments. So let's start off by defining some useful words. What is a subject? The subjects are the individuals participating in a study. And a study, there are two types of studies, an observational study and an experiment. An observational study is when researchers get information from participants through observations or questions, but the participants are in their natural state. Basically, the participants, basically the subjects, are how they always are, and these researchers just get information on how they normally are. Whereas in an experiment, researchers don't just observe the subject, but they apply treatment to the subjects in a controlled situation and studies the outcome. So let's try to look at this more visually. So in an observational study, this is the subject. He is in his natural state. And we, as the researchers, take note of how he is, how he behaves, what are his opinions, etc., in his natural state. But that, of course, depends on the goal of the observational study. What's important for you to know is that the subject is how he is. This is how the subject is how he always is. But in an experiment, let's say that this is a subject, and we give him a certain medicine, and we, as the researchers, take note of what happens to him after consuming the medicine. So now we are noting down the difference between how he was before and how he was after the medicine. So now in this situation, he isn't in his natural state. And that brings us to the next important word, factor. So what's a factor? A factor is the changed variable that is being treated to the subjects whose effect is being studied. For example, a medication can be a factor. In one way, an experiment is much better than an observational study is in cause and effect relationships. If you're trying to find the cause and effect relationship of something, an experiment is much better than an observational study. I'm going to give you an example right now. So you're trying to find out if a certain medicine is can heal a certain sickness, or the other way around, if this certain medicine is the cause of this certain sickness, then experiments are much better than observation studies, because you have to be able to test the difference of what will happen after the person takes this medicine. Whereas in observation studies, where you're just observing the person in its natural state, maybe you would get it some way, but it's much more difficult in observation studies than it is in experiments. Let's say that we are trying to prove if medication X can cure COVID. So what do? We ask somebody with COVID to take medication X. And after they do, we know the results down. Let's say that they got cured. That's a wonderful thing. They don't have COVID anymore. Now we have to ask ourselves, why did they get cured? Was it because they took medication X? Or was it because they ate carrot for lunch? So how do we answer that question? We need a control. What's a control? I'll explain it through this example. Let's say we got a completely different person with COVID, and we're trying to prove the same thing. We're trying to prove that medication X can cure COVID. We are giving this person medication X and a carrot for lunch. But this time we have another person who has COVID. We have another completely different person who has COVID, but we're not giving him medication X, we're only giving him a carrot. Now, the second person in this case is the control. If the first person gets cured, then and the second person doesn't, then we are pretty sure that it's because of medication X and not because of the carrot. But if both of them get cured, then that means there's a very high chance that the carrot is the one that's curing the person. So to avoid this error, we always need to have a control. Whenever you're conducting an experiment, you're going to have two setups. One is where the person gets the medication, and second is where the person doesn't get the medication. The lifestyle of these two people should be exactly the same, other than the fact that this person is getting the medication. So the only changed variable, the only factor here for the first person is the medication X. Other than that, every single other variable, like how I mentioned the carrot, the food they eat, the amount of time they sleep, every single thing should be exactly the same, unless it's something that you're 100% sure isn't the cause. So it doesn't mean that both of them have to drink 100 milliliters of water. It doesn't have to be that specific, but if you're 99% sure, even if you're 1% unsure of whether this could be a variable that would affect the results, then it has to be exactly the same for both the setups, just like the carrot. If we are unsure, if I think, maybe the carrot might affect the results, then both of them have to eat the carrot, or both of them should not eat the carrot. A confounding variable is when there's a variable like the carrot, but you do not take note of it. You think that there's a 100% chance that the carrot doesn't affect it, but it does affect. But it does affect the results, but you didn't take note of it. That is a confounding variable. And one way you can dodge a confounding variable and not make that mistake is by having a big sample. If you have a big sample where you got 20 people in medication X, the setups, and 20 setups of the control, every single person who took the medication X got cured, but maybe one person from the control got cured, then we can still very strongly say that medication X is the cause for the curation of COVID. But if you only have one person from each and both of them got cured, we really do not know. So that's why sample size is very important. If the sample size is big, maybe 20 is a respectful sample size for an experiment. If the sample size is 20, of course that depends on your budget too. Then if even if one person from the control actually gets cured, and but every single person from medication who took medication X got cured, we can still pretty strongly say that medication X is the cause of the curation of COVID. Now let's talk about three different types of controls. Sometimes the controls get no treatment at all, like what we talked about earlier, that they did not get any treatment at all. But sometimes they might also get treatment they use every day but doesn't work. Of course, that basically is similar to not no treatment at all. But one thing I want to talk about specifically is the placebo pill. So what is placebo? Placebo is when you give a person with COVID medication X, but actually it's not even real medication X. It's just a fake pill. It's a fake pill, and you give him this fake medication X and he doesn't get cured. That's called a placebo. But one thing that's important about this is called the placebo effect. The placebo effect is when you give the person a fake pill, the fake medicine X, but they still get cured. And of course, that feels unrealistic because it's not a real medicine, but it is actually a proven thing. Placebo effect is real, and sometimes there are situations where you give the subject a fake treatment and they get cured by it. This must be taken into account. You can't just say it's the placebo effect. Okay, it's all right. I'm not going to take that into account. I'm not going to note it down. But no, it has to be taken into account. And finally, to end off this video, let's talk about ethical issues. Let's say that he is the subject and we are the researchers. We are trying to find out how smoking affects the lungs and we are doing an experiment on it. In this situation, we cannot force the subject to smoke because that will be unethical. So in situations like these, experiments do not make any sense because we need a person who didn't smoke before and then who smokes now, and then we have to find out the difference. But if we cannot just force a person to smoke. So in this situation, instead of doing an experiment, an observational study would be much more smarter. And if you want to know, if you want to watch a video on observational study, I've already made it. I'm going to put it down in the description below. And that's it for this video, guys. If you've learned something new, please consider leaving a like. If you want to watch more videos on statistics like this, I made a playlist on statistics. Go check that out and subscribe to my channel for more videos. Thank you very much. See you next time.